Hello everyone, we are from group 2 and we will gonna present about the Epr Paradox and quantum entanglement. Before we start our presentation, let me introduce you guys the members in our group. We have FARIZAH KISNO, BELLVENA SONIA BINJAMIN, VILARIE OLGA ULIN, and FATIHAH BINTI AMIN. Firstly, we're gonna talk about the Epr Paradox. Epr Paradox was introduced in 1935 by Einstein, Boris Podolsky, and Nathan Rosen. It is a thought experiment intended to demonstrate an inherent paradox in the early formulations of quantum theory. It is among the best known examples of quantum entanglement. The paradox involves two particles which entangle with each other according to quantum mechanics. It seems that our consciousness plays a role in quantum mechanics. Einstein became uneasy about such implication and in later years organized a rearguard action against quantum mechanics. His question, "Do you really think the moon isn't there if you aren't looking at it?" highlights the depth of his distaste for the role of the consciousness. This is about the Einstein-Podolsky-Rosen paper. Einstein believed that while quantum mechanics could be used to make highly accurate statistical prediction about experiments, it's an incomplete theory of physical reality. In the May 15, 1935, Einstein, working with the physicists Boris Podolsky and Nathan Rosen, published the paper "Can Quantum Mechanical Description of Physical Reality Be Considered Complete?" In this paper, they conclude that quantum mechanical description of reality given by the wave function is not complete. That is, there must be a hidden variables that we don't know about and hence don't measure that cause the uncertainty.
Hi, I'm FATIHAH. About John Bell showed in a 1954 paper entitled "On the Einstein-Podolsky-Rosen Paradox" that local realism leads to a series of requirements that known as Bell's inequalities. Bell came up with a complex experiment if EPR is correct or wrong. If they were right, then quantum mechanics is wrong. On doing experiment, he found that EPR wrong and quantum mechanics is correct. This means that particles is communicating faster than speed of light. Next, I will briefly explain the implicit assumptions of EPR. Firstly, the principle of reality. Individual particles possess definite properties even when they are not being observed. Secondly, the locality principle. Information from a measurement in one of two isolated systems cannot produce real change in the other, especially superluminally. Taken together, these two seemingly obvious principles imply an upper limit to the degree of coordination possible between isolated systems or particles. Interestingly, they both turn out to be wrong.
Hi, this is VILARIE Olga. As you can see on the screen, our next topic is quantum entanglement. Do you know what it is? Quantum entanglement is the physical phenomenon that occurs when a group of particles are generated, interact, or share spatial proximity in a way such that the quantum state of each particle of the group cannot be described independently of the state of the others, including when the particles are separated by a large distance. In a simple explanation, quantum entanglement is one seriously long-distance relationship. Quantum entanglement is when two particles link together in a certain way no matter how far apart they are in space, and their state remain the same. Now, let's watch a video about practical example of quantum entanglement. Imagine that you are on a long drive when you suddenly hear your stomach begin to grumble. You decide to head to a fast food joint where you order a hot dog and a burger. but they put in similar boxes and hand to you through the window. You have no way of knowing which box has the hot dog and which has the burger. Obviously, once you open one of the boxes and see a burger, you will immediately know that the other one has the hot dog. This means that the hot dog and the burger are entangled in a certain way. This is roughly the idea upon which quantum entanglement is based.
Hi everyone, my name is BELLVENA SONIA BINJAMIN, and now I'm going to talk about Introduction to Quantum Entanglement. Albert Einstein, Boris Podolsky, and Nathan Rosen introduced the concept of entanglement in 1935 in an attempt to demonstrate that quantum mechanics is not a complete theory. This includes a discussion of what is reality and what is a complete physical theory. They examined how strongly correlated quantum states would interact with each other. Then, they found that when two particles are strongly correlated, they lose their individual quantum states and instead share a single unified state. This unified state would become known as quantum entanglement. They found that if two particles are entangled, meaning their quantum states are strongly correlated and become unified, then measurements of one of the particles automatically influence the other, no matter how far away the particles are from each other. The first physicist to use the word entanglement was Erwin Schrödinger, one of the founders of quantum mechanics. He described entanglement as the most essential aspect of quantum mechanics, saying its existence is a complete departure from classical lines of thought. Quantum entanglement is one of the concepts that led Albert Einstein to dislike the theory of quantum mechanics. Einstein called entanglement spooky action at a distance because he did not believe that quantum particles could affect one another faster than the speed of light. He tried to show that this weird effect means that quantum mechanics give an incomplete picture of what really goes on and that in the future it will be taken care of with extra hidden variables. Now, quantum computing is an area of computing focused on developing computer technology based on the principles of quantum theory. It explains the behavior of energy and material on the atomic and subatomic levels. Quantum computing is made of qubits, and unlike a normal computer bit which can be 0 or 1, a qubit can be either of those or a superposition of both 0 and 1. Superposition and entanglement are two features of quantum physics on which these supercomputers are based on. This empowers quantum computers to handle operations at speeds exponentially higher than conventional computers and at much lesser energy consumption. Teleportation. We may not be able to teleport objects or people from place to place in an instant, but there are scenarios where teleportation can be achieved. Scan and reassemble type of teleportation is actually possible thanks to quantum entanglement. Quantum entanglement occurs when two or more particles are forced to hold mutually exclusive states, so determining one simultaneously determines the other. If we have two entangled particles, knowing the state of one will automatically tell you the state of the other as well. This is independent of distance, which means we can use entanglement as our teleportation method.
That is all from us. Thank you so much for your interest and attention. Thank you.